Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about conditional distribution function and conditional density function. In, in my previous videos, we have already discussed about concept of conditional probability. So we know that the conditional probability of event capital A given the event capital B is given by or written as probability of A by B is equal to probability of A intersection B by probability of B. So this is the conditional probability. This concept we have already discussed in concept of the probability. Let capital A be an event x less than or equal to x for the random variable x. If the event B is given, the conditional distribution function of the random variable x is fx of x by b is equal probability of x less than or equal to x by b. So using this conditional probability of the definition, probability of x less than or equal to x by b is probability of x less than or equal to x intersection b divided by probability of b. The event can be defined from some characteristics of physical experiment. It may be defined in terms of the random variable x or some other random variable other than x. Some other random variable. That other random variable may be y or b other than x. And the first one is okay. The random variable may be defined in terms of it may be defined in terms of the random variable x or some other random variable. There are two cases, and the first case is if the event b is defined in terms of the random variable x, so that event b is defined as capital B is equal x less than or equal to b, where the range of the b is minus infinity to plus infinity. So therefore, the conditional distribution function fx of x by b is equal to fx of x by, now here event b is defined as x less than or equal to b. So fx of x by x less than or equal to b, which is equal probability of x less than or equal to x by x less than or equal to b. So using conditional probability definition, this is the conditional probability definition. So using this definition, RHS term of this equation is written as probability of x less than or equal to x intersection x less than or equal to b divided by x less than or equal to b. So this conditional probability distribution expression can be explained into two cases, and that are small b less than or equal to x and small b greater than x. And the first case, for small b less than or equal to x, this numerator term, that is probability of x less than or equal to x intersection x less than or equal to b, is only probability of x less than or equal to b. And the second case, b greater than x, this numerator term is only probability of x less than or equal to x. So that is first case. If b less than or equal to x, numerator term becomes x less than or equal to b. Okay, applying that condition into b less than or equal to x, we get the conditional distribution function expression. Probability of x less than or equal to x intersection x less than or equal to b is probability of x less than or equal to b numerator term. So now we have the numerator denominator is the cancel, which is equal to 1. And the second case, if b greater than x, probability of x less than or equal to x by x less than or equal to b is equal probability of x less than or equal to x. Applying this condition into probability distribution function expression, we get fx of x by x less than or equal to b is equal. So numerator term here, in this case numerator term becomes probability of x less than or equal to x by denominator term. And the numerator term is the probability distribution function of the random variable x, and the denominator term is the probability distribution function, that is fx of b. Okay. So finally, the final expression of the conditional distribution function can be written as fx of x by x less than or equal to b is equal fx of x divided by fx of b for x less than b, and fx of x by x less than or equal to b is equal to 1 for x greater than or equal to b. And that is the expression of the conditional distribution function. The corresponding conditional density function is given by small fx of x by x less than or equal to b is equal. So what is the general definition? The density function is equal to derivative of the distribution function. So using that concept, the conditional density function is equal to derivative of this conditional distribution function. So derivative of this numerator distribution function is density function of the random variable x. So this denominator term, and also one of the property of the distribution function, the distribution function is equal to integral of the density function, and the denominator term is integral of the density function. Therefore, the conditional density function of the random variable is fx of x by x less than or equal to b is equal, numerator term is density function of the random variable divided by denominator term is, so using the property of the distribution function, the distribution is integral of the density function, that is integral minus infinity to b fx of x dx for x less than b, and 1 derivative of 1 is 0. So 0 for x greater than or equal to b. So the event capital B is defined in terms of another random variable. And previous one we have discussed about if the event B is defined in terms of the random variable x. Now here event B is defined in terms of another random variable. That is, if the random variable capital X is conditional by a second random variable y, where y less than or equal to y, it is called point conditioning. Y less than or equal to y, it is called a point conditioning. So fx by y of x by y is equal probability of x less than or equal to x by y less than or equal to y is equal probability of x less than or equal to x intersection y less than or equal to y by probability of y less than or equal to y. So provided probability of y less than or equal to y is not equal to 0. So simply fx by y of x by y is equal fxy of x comma y by fy of y. Okay, from this equation, so using the definition of the probability joint probability distribution function, this numerator term is the definition of probability distribution function of the random variable x and y, that is fxy of x comma y, and this denominator term is probability distribution function of single random variable y, that is fy of y. If the random variable y is defined in such a way that its value lies between two constants ya and yb, that is between the interval y suffix a and y suffix b, so that between the interval is ya less than or equal y less than or equal to yb. So this is called as interval conditioning. So and the previous one is point conditioning. So and this is a interval conditioning. And what is interval conditioning? If the random variable y is defined in terms of between two constants, between two intervals. So that is ya to yb. So the corresponding conditional density function is given by small f x by y of x by y is equal derivative of the capital F x by y of x by y. Okay. Density is equal derivative of the distribution function. The density function is equal to derivative of this joint distribution is small fxy of x comma y, and derivative of this distribution function of the random variable y, density function fy of y. So from this equation, the corresponding density function is fx by x fx by y of x by y is equal fxy of x comma y by fy of y. So provided for y fy of y is greater than 0. So this is the concept of conditional distribution function and conditional density function.